This is part 2 of our lesson on rational exponents. In this part, we're going to take a look at what a rational exponent actually does. So here it says evaluate 9 to the power of 1/2. And I could type that in on my calculator, but I want to see if I can figure out something to do with 9 to the 1/2. We've never seen an exponent that's a fraction before, so this is pretty new to us. So what I'm going to do is I'm going to make up a question that uses 9 to the 1/2. Normally when we're trying to prove this, we try to come up with a question that has an answer of 9 to the 1/2, but this time I want to make up a question that uses 9 to the 1/2. So I'm going to pick 9 to the power of 1/2 times 9 to the power of 1/2. And I'm going to do two things with this. We're going to use slightly different exponent laws to help us figure out what 9 to the power of 1/2 times 9 to the power of 1/2 is. So on this side of the equal sign, I'm going to use my multiplication rule for powers. So if the base is the same, the rule is that you add the exponents. So 9 to the 1/2 times 9 to the 1/2 would be 9 to the 1/2 plus 1/2. Now to add 1/2 plus 1/2, you add the numerators. So 1 plus 1 is 2, and you leave the denominator, which is 2. And 2 divided by 2 is just 9 to the power of 1. Now on the other side, on this side here, we're going to do something a little different. I have 9 to the 1/2 times 9 to the 1/2. When you multiply something by itself, like say 5 times 5, we can write that as 5 squared because we've multiplied it by itself. So 9 to the 1/2 times 9 to the 1/2, I could also write that as 9 to the power of 1/2 squared because we've multiplied it by itself. And if I multiplied this out, 1/2 times 2 is 1, which gives me 9 to the power of 1. But I don't want to multiply it out. I'm just going to leave it as 9 to the power of 1/2 squared. Now here's the interesting part. If you had a square, so let's say we had x squared equals 4, and I wanted to solve for x, we would take the square to the opposite side by doing the square root to get x equals the square root of 4. So here, to take this square to the other side, we're going to take the square root of 9 to the power of 1. So 9 to the power of 1/2 equals the square root of 9 to the power of 1. And I'm going to leave it there for a second. We're going to try the next one, and then we're going to look to see if we see a pattern here. And I'm going to try the same thing. I'm going to make up a question that uses 8 to the power of 2/3. So I'm going to pick 8 to the power of 2/3 times 8 to the power of 2/3. I'm actually going to do it 3 times 8 to the power of 2/3. Now, how did I know that I should do that? Well, I'm the math teacher. That's how I knew. So here, if I'm multiplying, our rule is that if the bases are the same, we add the exponents. So since the bases are all 8, this is going to be 8 to the power of, and then we add 2/3 plus 2/3 plus 2/3. And 2/3 plus 2/3 plus 2/3 is 2 plus 2 is 4 plus 2 is 6 over 3. And 6 divided by 3 is just 2. So I end up with 8 squared, which is 64, but for right now I'm going to leave it as 8 squared. Now here on this side, I have 8 to the 2/3 multiplied by itself 1, 2, 3 times. So I'm going to say this is the same as 8 to the power of 2/3 to the power of 3 because it's being repeated 3 times. And I'm just going to copy that down onto the next line here. Now something that may be a little new to you, just like when you have a square, we move the square to the other side by doing a square root. If I had an x cubed, I could take it to the other side not by doing the square root, but by doing the cube root. So I would say x is the cube root of 4. So here I'm going to bring the cube to the other side by taking the cube root of that x squared. So I'm going to have 8 to the power of 2/3 equals the cube root of 8 to the power of 2. Now, I'd like you to take a second and think about what you see there. Might be a good time to pause the video so that you can think about what connection do you see between this and our answer, or this and our answer. Where do you think the 2 and the 3 or the 1 are coming from? How is it connected? So take a minute, pause the video, see what you think, and then when you're ready, you can unpause it and we'll talk about what the answer is. Okay, so what I notice when I look at this, especially for this one here, is that the 2 ended up being an exponent on the 8, and the 3 ended up being a cube root. On this one, the 1 in the numerator ended up being an exponent, and that 2, although we don't normally write it in, it is a square root, which means that really is a 2 in there. We just don't tend to write it in there because we use square roots a lot. So our rule for rational exponents is if you have x to the power of a over b, the a just works as a regular exponent. So you're going to have x to the power of a, and the b ends up being the root. So this would be the bth root of x to the power of a. Now there is one more way to write that. I can say x to the power of a over b. Instead of putting the a inside with the x, we actually could say that it's the bth root of x to the power of a. And it doesn't matter whether we do the power first or the root first, you do actually get the same answer either way. So the important thing to get out of this is that the a becomes our regular exponent and the b becomes our root. So in our next video, we're going to take a look at some examples.